Welcome back to part 9 videos on this data science series on linear regressions. Way too many videos, but there's a lot of good stuff that we've talked about. I gotta admit that. We've been really going into depth about some stuff. And oh, by the way, who am I? My name's Clifford Jordan. I'm with Science Foresight, and this should probably be the last of the series for linear regressions. All right, we just got through talking about confidence interval in the last video. This was the formula. And remember, you might have fallen into the trap of thinking that a confidence interval would help us predict or determine the probability that the predicted output of a model, of a linear regression, falls within this the confidence interval. That's not true. That's a prediction interval. Confidence interval is that the estimated slope or the coefficient of the dependent variable and the y-intercept, when used to create the trend line, has a 95% chance of falling within that interval. That's what the confidence interval is. Now, let's talk about the predicted interval. In fact, let's go back to that confidence. Here's what I'm talking about. Here's the trend line, and the idea is that, remember, by the trend line, we're using that as an estimate of what's really in the brain of the patron, as far as the sensitivity and the other measurement, which is the average spend without coupon. What we're trying to do is estimate what's really in his brain, and what we're saying is that there's a 95% chance, we use the 95% confidence interval, that what's really in his brain falls within the red dots up here and the red dots down here. That's all we're saying. What we're going to talk about now is a prediction interval. What a prediction interval will tell us is, we can specify the interval like a 95% prediction interval, is that the predicted output will be has a 95% chance of being within another interval, which will be a bigger interval, because to get all these points in there, we need a bigger interval, right? So let's go back to the raw data and figure that out. But before we go there, let's first, well, we can go there, but first we're going to go back and we're going to look at the actual equation, the formula for the prediction interval. Now, it looks very similar to the confidence interval. Here's your y hat, which is your predicted output. In fact, this should be y hat sub I, because it's one for every row. Okay, so just imagine there's a little sub I there. Plus or minus, and then all of this right here is what we call the margin of error. Okay, and so everything's pretty much the same. This is depending on the number, this helps us determine the number of standard deviations that are going to be part of, that we're going to use in the margin of error, based upon the amount of confidence. If it's a 95%, it's going to be a bigger number. If it's 20%, it's going to be a smaller number. The SE is the RMSE value, or the standard error, square root of, and then what we had before was this 1. What we had before was this 1 over n, and then all this other stuff was exactly the same. What's different is that we're adding a 1 here. And what that 1 does is it opens up the total margin of error. It gives us a bigger margin of error. And that's the only difference between the prediction interval and the confidence interval, is this 1 right here. Okay? That said, let's go back to the data now and let's look at it. All right. If I go right here, go up here and click on it, you can kind of see this is the prediction interval. Now, it's pretty much the same as we saw before for the confidence interval. The only difference is this has a 1 right here. Okay, I don't know if you can see that up on see that 1 plus? That is the only difference. And so the same thing here for the high end, you got that 1 plus. So everything else is the same as it was for the confidence intervals. So let me go ahead and uncover all this. Bingo, it is now uncovered. Sure enough, if you look at the difference between the confidence interval, the confidence is between 84 and 106 for this particular x. Okay, but look at the prediction interval, much bigger. It's between 17 and 173. Why is it so big? Well, it has to do with this 95. I wanted a 95% confidence in my predictions. So it had to create a big interval for those predictions to fit in. Okay. Also understand that I have a lot of variance in the system. If I had less variance in the system, and we're going to experiment with that, that confidence, or everything, all my accuracies are going to go down. Or all my accuracies are going to be better. Let me say that. The errors will go down. The accuracies will be better. And that will have effect of making my confidence interval smaller. So the less variance in my original data, that will impact my confidence interval to be smaller. Okay? We'll experiment with that. Just give me a minute. Let's go back and add these confidence intervals to the graph, to the scatter plot. So we're going to go over to the scatter plot. Here, oh, excuse me, I said prediction interval, didn't I? We always get these two mixed up all the time. But anyways, here is our confidence interval that we plotted from the last video. Now let's add the prediction interval. I'm going to go over here, say select data, add. I'm going to call this predict underscore low. X values are the same as we've seen before, raw data. Come up here, highlight the X values. Come on. Okay, Y values are going to be the predict low. Bingo. There we go. Hit OK. Now let's do add. Let's go predict high. Predict high. And the X value is going to be the same. Let's go back to the raw data. X value, doobie-doobie-doobie-doo. There, and Y values are right here. Come on, get there. Okay. Hit OK. Hit OK. And there we go. So you see these values up here, this line, kind of light blue. We're going to change the colors on that. Marker. Let's make these green. I like green. Green. Let's make them green. And let's make the bottom ones green too. That's yellow. That's ugly. Okay. Just go over here and change it to green. Green. Bingo. So they're now green. Okay. So what this means is that whatever I predict that's in the range between $0 and $10 for coupon value has a 95% chance of being within these two green lines or green boundaries. Okay. So if you look at the actual data that we have now, I think it all fits within the green boundaries. So the only ones that are close is like right here. And then we got some, this guy down here is really close as well. But actually, in the data that we have here, it's like 100%. But it doesn't always. I mean, it's supposed to be 95%. So we just lucked out by getting 100%. But let me hit F9. Let's change the data up, see what happens. Here we got F9, and it looks like everything's within the confidence interval. Let's go F9. Let's see if we can find one where we got an outlier. Come on. Show me an outlier. Yeah, I might have to hit this like 95 times before I get an outlier. Dang it. Come on, show me an outlier. I'll tell you what, I'm going to force it to be an outlier. What I'm going to do is go back to the raw data. If I go up here, I chose a 95, which is a 95%. That's a really big cover. Let's make it smaller. I'm going to put an 80. 80. No, let's put a 50. Just for fun. 50%. If I go back to the scatter plot, hit F9, bingo. Oh! So notice that the green dots are now well within the data. What this means is about half of these data points are outside the green dots, and half of them are in. About half. Okay. So that's what that means. So this is your prediction interval. You set what you want. You want a 95% prediction interval? 95% of the time, your predictions will be within that interval. If you want a 50%, 50% of the time it'll be within. Now, typically, everyone likes 95% because hey, it's fairly sure. But remember, you can be whatever you want. A lot of times in marketing, we may go for something a little bit less, like a 70%. Okay, it doesn't have to be 95. But if you're doing anything in the medical industry, you probably want like 99%. You know, because you're dealing with people's lives here. So there you go. This is our confidence interval. Excuse me, our prediction interval. The red one is the confidence interval, and the trend line is the one in the middle. And then all the blues are the actual data. So, there you go. I think we've about beat this horse to death. As far as linear regressions, we have, in summary, we've taken data, behavioral data, which is in these two columns. This is our dependent variable, which is the y, the independent variable, which is the x, which is the coupon value, the y is the total purchase. And we did a linear regression manually, and through that we estimated the slope. And another way of saying the slope is actually just the coefficient to the x variable. Okay, that's going to be important when we go talking about multivariable linear regressions. Right now we just have one variable. When we go to multivariable, you'll think of it more as just a coefficient. So we're estimating the coefficient to the x variable, or also the slope. We're also estimating the y-intercept. Okay. And we calculated all the error measurements that you will typically see in any linear regression. And we also calculated the standard error, the t-value, and the p-values for both the slope and the y-intercept. And we calculated the f value. And I really can't think of much more to do. We also calculated the r-square value. I think we pretty much got it all. Oh, we did the confidence and the prediction interval. So whenever you do a linear regression, and if you're not going to do it manually. If you do it manually, you're torturous. You want to use a tool like R, or maybe Excel. You can actually use the analytics package in Excel, or you can use SAS or whatever package or software you got. But please don't do it manually. But when you do it, they're gonna show you the values of all these things that you've seen here. You're going to see them on the output. Now, I hope, as a result of these videos, you have a better understanding of what those values are and how they relate to the data. How, when the variance changes in the data, how that impacts each of those variables and what those variables really mean. You don't know how many times I've seen people talk about p-values when they really don't understand what a p-value is. Or r-squared. That's even worse. I hear that all the time. Oh, my r-squared is this, blah, blah, blah. Really don't understand what an r-squared value is. But here, we can actually see it, and we can better understand it. Okay? So, there you go. I congratulate you for going through the 8 videos. Or is it 9? 9 videos! Holy cow, you've gone through 9 videos. You may have even gone through the 2 prerequisites, which was on normal distribution and the slope-intercept formula. So if you've done that, hallelujah, congratulations, you've done well. And go out there and practice. We're going to do another series where we're going to actually look at this, and we're going to probably do this in R. And then we'll probably look at do a comparison between what the Excel spreadsheet did, what shows, our manual calculations versus what R shows. And that will hopefully even give you a little bit more faith in what we've done in these videos. That said, if you have any questions, please, you can get a hold of me at guru@scienceforesight.com. All right, and I will make sure that this spreadsheet is made available to you, so you can actually look at it and follow along, and maybe make some changes yourself. So Thank you very much. And stay tuned. We're going to have more series coming out soon. Ciao.